WebEx works, it takes it like about till the next day to process. So I should have today's session posted tomorrow. So mainly what I want to do is use this time to let you ask whatever questions that you're interested in, whatever those may be. I thought I'd start with a few general words about what the test is going to look like, and then we'll just kind of open it up from there and see what you'd like to look at. So as you know, there are actually two tests, the final exam for Math 0232 and test 4 for Math 1332. I've got both practice tests open here. One change that went out by email yesterday, I was originally planning for these to be 90 minutes, and the tests are written as 90-minute tests. You should be able to finish in 90 minutes. But I got to thinking that if this were a regular test, a regular class, still meeting face-to-face, that you would have the full 2 hours allotted to final exams. And so it just seemed fair. Maybe it'll take some pressure off too, that both of these tests will have 2-hour time limits. And they open up Thursday, that is tomorrow, and will be open all the way through Sunday for you to log in and take each one at whatever time you find convenient. Calculators obviously are welcome on both tests. I think that's all. Oh, and the tests themselves are about half as long as these practice tests. Practice tests are designed to be kind of long on purpose to give you lots of chance to practice, but the actual tests are about half this long. So that's just a few general words. Again, questions will be very, very similar to what you see. Let me just kind of open this up and see what you would like to ask. You are our only guest at the moment, so you can ask anything you like. Any requests? I see you have your microphone unmuted, but I'm not hearing anything. I don't know if that means you're looking for questions or if you actually have a question. Do you have anything? I see the chat is open. Okay, excellent. So yes, I see your chat. So we're going to go with that. The only thing I mainly need help with is the difference between the NPR and the NCR. That's perfect. That's perfect. Good question. You know what? I have a handout here. This is the handout I used to create one of my videos. Give me half a second and I will pull this up. Hold on just a second, because it'll help me talk through this. Hi, Megan.
Hi.
How are you?
I'm good, and you?
Good. We are looking at I think this is right. Let me see. Nope, that's not right. It's this one. You know what? Let me open it this way. Okay. So the question that has come up so far that we're addressing is kind of in general, how do you decide between permutations and combinations? So I created a video that has this little slide in it. Let me make it bigger so we can see it better. And I think this little chart helps me understand whether you can use either of the formulas, and if so, which one. So if you have a counting question, the first thing you want to ask yourself is, am I selecting R objects out of a larger set of N objects? If I'm selecting a few out of many, then I may be able to use one of these formulas. Then the objects have to be chosen without repetition. You can't have any repeats. If you have any repeats, you can't use either formula. Now, if it looks like you're selecting few out of many, and if it looks like you can't repeat objects, then you're definitely going to be able to use one of these two formulas. It's just a matter of deciding which one. The way you differentiate is you ask yourself as many of these questions, these next two questions, as help. You want to ask yourself, are you interested in the way the objects you're chosen is arranged? Or are you simply interested in the set of objects? Or to say it another way equivalently, is the order important? The objects, if you look at the context of the problem, is it important where the order, how they're ordered, or is order not important? If you're looking at arrangements and order is important, you use permutations, NPR. If the order is not important, you use NCR. So I might just take a look at a couple of these examples. These are from a handout that was sort of my rough draft of the video, but maybe it's a good place to start. A club has 15 members, and how many different ways can you select a committee of 4 members to plan a party? So the way I would think through this is I'd say, am I picking a smaller number of objects from a larger set? And feel free to chime in either by chat or voice. Does it make sense that we're picking a few objects from a larger group?
Yes.
Okay, good. So that's helpful. So we made it through sort of stage 1. The second stage is, are the objects chosen without repetition? No object is used more than once. So there you have to kind of think about the scenario. If you're picking people, is there any way you could pick the same person twice when you're creating your set? And I think that doesn't make sense. If you were saying, you wouldn't say, George, you're on the committee. George, you're on the committee. You wouldn't say that twice. So I think it's true that the objects are chosen without repetition. So I think we're okay for both of the first two options, and we should be okay to look at either arrangements or subsets. Now, do you care about how the members of the committee are arranged? Or do you just care about who the people on the committee are? And that may take some getting used to, but you might think of, so I pick my committee of 4. Do I care in what order they're sitting around the table? Does that make any difference? If one gets up and trades seats with another, does that make it a different committee? What do you think? Is order important? No, I see a no by text. That's perfect. Right, order is not important. You're just looking at the subset. So that tells me you are right over here. You're going to use this formula. Okay. And the way you would do that, since I've got my calculator open here, is you think the N is how many objects you have to choose from. The R is the number of objects you're going to choose. So there's 15 people on the committee. That's going to be your N. To get to the NCR, you have to go math, slide over to probability. This is kind of hiding behind a window here. And then slide down to NCR, choose that, and then you're picking 4 out of the 15 So it's 15C4, and that's your answer. Does that make sense so far? Good, good. Okay, let's pick a couple others. Well, let's just take a couple in order and see if that gets the idea, and then we can do more as however we need. How many two-letter codes can be formed using the letters A, B, C, D, and E if repeated letters are not allowed? Are we selecting some objects from a larger set? Are we picking a few out of a larger set? Hopefully you see that's true. You've got the 5 letters to choose from, and you're going to pick 2 of them. So you're picking 2 out of 5. You may be in the right scenario. Objects are chosen without repetition. It says right here, repeated letters are not allowed. So if you make it through step 1 and step 2, you're going to be able to use one of the formulas. It's just a matter of which one. Now, imagine creating a code. So like this is a 2-letter code, that's not much, but if you think about maybe the code you use for your ATM card or something like that, does the order of the numbers matter, or does it not matter? Are you worried about how the numbers are arranged, or just what they are? What do you think? Is order important?
I'm gonna say no.
You gonna say order's not important?
But
Okay. All right, let's think that through. Let's think that through. So think about your the code you use for your ATM card. Let's say it's 1, 2, 3, 4. You you pick something really much too easy. If the order is unimportant, then you should get away with either entering 1, 2, 3, 4 or 4, 3, 2, 1. Would the bank machine be okay with that? I think Shelby, I don't know if you can see the text, Megan, but Shelby's saying that the order matters there. I think it does. If in a code,
yes.
you change the numbers around, you've got a different code. So here the order is important. You're caring about how those letters in this case are arranged. So that shoots you down this column. Okay, that's kind of the thought process you go through. So this time you're going to use permutations. Once you know the formula, it's just a matter of who's the N and who's the R. What do you think the N would be this time? N stands for the number of objects. Yes, 5. You're choosing from a group of 5 numbers. So I'm going to start with the 5. It's NPR. So I go this way and over this way and down this way. And so 5 is the number of elements you're choosing from, and the number of elements you're choosing would be what? I just held my fingers up. I didn't mean to do that. 2, exactly. You're choosing 2 out of 5. So this would be permutations P5P2, and that's your answer. That kind of makes sense with the thought process. It's the thought process that's the big thing. Once you've got something, it's just punch it in the calculator and you're done. But it's the thought process. That's the big deal. What if I looked at number 3? 3 is the same scenario as number 2, but repetition is allowed. Can I use one of these formulas if I change that wording? No, I can't. Yeah, for the formulas to work, objects have to be chosen without repetition. And if I'm allowing repeated letters, sorry, then you can't use either formula. So what you fall back on then is the fundamental counting principle, which says, look at whatever you're creating as a sequence of choices and ask yourself, how many choices do you have at each stage? So if I'm picking a 2-letter code, First I think about what letter do I pick for the first letter, and it can be any of those 5. So I have 5 choices for whatever I pick first. Then when I go to pick the second letter, because repetition is allowed, I can still pick any of the 5. So I just say 5 times 5. And the answer is 25. So sometimes the formula doesn't work. Neither formula works, but what you fall back on is that fundamental counting principle. Does that help? Good, good. Maybe you want to look at just a couple more just to make sure we're comfortable with that. These are examples I put in my video, but you probably haven't seen it for a while. So let's just talk through a couple more. Oh, that's right. I changed this up because I don't know if I think the rules for Lotto Texas have changed, but we'll just assume this is correct. Lotto Texas is played by choosing 6 numbers out of the whole numbers from 1 through 54. Winning occurs if these numbers match the numbers chosen on the balls in any order. How many possible choices of tickets are there? So let me see if I can get this and the chart on. Oh, good, I can. Okay. So let's talk through the stages here and see if this makes sense. Are we selecting a certain number of objects from a larger set? Yes. Oh, okay, great. We've got a from Shelby here. She's just gotten the answer. This is exactly right. She's saying 54C6. That is precisely right. We are choosing a smaller number of objects from a larger number of objects. The objects are chosen without repetition. It would not make any sense to pick the same number twice when you're filling out your card. There's no way, because the little ping pong balls all come up with different numbers. So you would not repeat numbers. And either from knowing how Lotto wins or just reading right in here, the order doesn't matter. The order in any order. So the order doesn't matter. We're right here in combinations. It's going to be 54 C and how many numbers are we choosing again? 6. 54C6. That's exactly right. And that's this very large number, 25,827,165. So since only one choice of numbers wins, what that means in the language of probability, which we start talking about a little bit later, is that your probability is 1 out of 25,827,165 that you'll actually pick the winning numbers. Good. Does that make sense? All right. Great, 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 great. Let's look at number 7, and then I want to go back to these others here. How many 4 suspect lineups can a police department create if they can choose any of the 15 men currently in jail? So think through the process again. Am I choosing a smaller group of things, whatever they may be, whether they're numbers or whether they're people? Okay, I've got a vote for combination. Let's think about that. I think we are definitely choosing a few out of many, and we're not going to repeat people. We wouldn't have the same person up there twice. Thinking about what a lineup looks like. So I'm thinking about the last time I saw CSI Miami or something like that. And they've got all the people lined up. And this may be not quite as obvious, but how many different lineups are possible? Is the order of those people, would the order of the people make a different lineup, or would it not? I'm getting both of y'all saying no. And you know what? I think this one is, and now I'm getting a yes. So I think maybe this one's a little bit vague, and I promise you I don't have any of this vague. But what I was thinking when I designed this is the lineup would indeed look different if I had, Rocco over here on the left versus Rocco over here on the right. It would look different. So it's the same people, but the lineup would be different, whether you put Rocco on the left or the right. Thanks for the LOL there. So my thought when I created this is that the order is important. I promise you all the questions on the test are not vague. So the order, I'm going to say the order is important. So that would make it a permutation. Does that make sense? Let me try one that's less. Oh, do y'all need to see me do the calculation on that? I'd be happy to. Or do you think you got it? Okay, good. Let me back up. I want to do these questions with cards because there's a really important extra lesson that I want to bring out when I do these. But starting with number 5, how many different 13 card hands can be dealt from a standard deck of 52 cards? So we're again thinking about, am I choosing some out of a larger group? Yes, this is the answer to 15P4 is the correct answer to the question about the lineup. That's right. That's right. Let's see who said that. Shelby. Yes, you're right. 15P4. In this one, we are choosing few out of many. Could you have repeated objects? Could you get the same card twice, in other words? No, no way. Well, assuming it's a fair deck, right? So you would not get the same card twice. There's no way you'd have repeated. So that tells me that I'm going to be able to use combinations or permutations. It's just which one. Now, thinking about how you might play cards. So 13 cards, this would be playing bridge. I don't play bridge, but I know people who do. You get all your cards. Do you care what the order of those cards was when they came to you? Does that matter what order they came in? Could you rearrange them in your hand, and would that make it a different hand if you just rearranged everything? You know what? I asked 2 questions, and turned it different ways. So I'm not sure which one we're saying yes to. So let me be more careful here. Is the order important? And I'll give you a second. Right. That's correct. That's correct. The order is not important. The order is not important. You don't care about the order. That tells me that we're going to be looking at combinations. Okay. So we have 52 cards, and we're choosing 13 of them. 52. And we're going to go with NCR. And we're looking at a 13 card hand. So we're picking 13 out of 52, order not matter, combinations, and that comes out like this. Now this number is in scientific notation. That E is calculator shorthand for times 10 to the 11th power. If you got an answer like this, I would probably say round it off to 2 decimal places, and you'd say something like 6.3 times 10 to the 11th power. So that's like a whole lot of different options. Is that okay? Great. Now, this next one and a couple others, there's a little subtlety to these that I want to point out. So number 6 looks like it's like number 5 until you look at it a little bit more carefully. From a standard 52 card deck, how many 7 card hands have exactly 5 spades and 2 hearts? So when you start through that, you think, okay, this is basically the same question, you're dealing out the cards, so you don't care about the order and you can't have repeated stuff. So there's going to be combinations involved. But what makes this one a little different from number 5 is on number 5, you're just picking any 13 cards out of all the cards. In this one, you care about where those cards come from. So you're choosing some from many again, but you want them to come from the right place. So for example, you want among these 7 cards to have 5 spades. So what you want, and I think this should work, yes. So you want to choose 5 out of however many spades there are. We'll think about that in a minute. And 2 out of however many hearts there are. So I'm being more specific. I'm choosing 5 out of the spades and 2 out of the hearts instead of 13 out of everything. Does that make sense? So what we're going to do is we're going to think about these individually and then figure out how to put them together. And this does require a little bit of knowledge of what a deck of cards looks like. So if you're not a card player, it's a little bit harder. How many spades are there in a deck of cards? 13. 13. 5 out of 13 spades. How many hearts are there? Same answer. So we agreed on combinations. We're going to be choosing, let's start talk about the spades first. 13 spades. We're going to choose from that how many did I say? 5. Okay, so 13 C5. Now I could do that number separately, but I want the calculator to do it all at once. The other number I think you could probably see would be 13C2 because you're only going to choose 2 out of the 13 hearts. The question is, how do you take those 2 separate numbers and put them together? Well, what you want to build on there is that underlying everything in all of counting theory is that fundamental counting principle. That's what backs up everything. And in the fundamental counting principle, what's the operation that's used to take each individual number and put them together? Do you add, subtract, multiply, divide? Multiply, right. So in this example and any other, if you have a situation where you're picking some from some group and some from another group, when you get those numbers separately, you'll be multiplying them. So on your calculator, if you have one of these newer versions, notice I'm still down here in the subscript. I have to use my arrow button to get out of that. And then I start typing, then I put a multiplication symbol because I'm going to multiply. And then I'm going to say 13 math, roll over here and down here. And we're only picking 2. So notice the calculator can do everything all at once. You don't have to like do part of it, write it down, do another part, write it down. It'll multiply 13C5 times 13C2 and get all that for you, and bingo, that's the answer. What do you think? Does that look all right? Good, good. I want y'all to look at number 8. And I want to give you a second here and let you think through the whole process we've talked about, including this bit about you maybe have some from one group and some from another. Tell me what you think the calculation ought to be. And you can write it, since you don't have the ability to do all these subscripts and stuff, you could do things like 9C7 or something like that. Not that those numbers are meaningful. Let's see what we got. So I have from Shelby, 6C3. That's choosing 3 out of 6 Republicans, times, because it's the fundamental accounting principle goes underneath everything, 5C2. That's perfect. That's exactly right. 6C3 times 5C2. That's exactly right. Let me just write it up here so you can see it better. 6 C3, get out of the subscript, times 5 C2. That will do it. That's exactly right. The order in a committee, the order of the people wouldn't matter. So you're good with combinations, and you're picking 3 of the 6 Republicans, 2 of the 5 Democrats, and then putting it all together, and you're going to get that answer. Good. That's coming along well. Are y'all feeling more confident with that process of deciding? Great. Megan, what do you think? Good, 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 good. Excellent, excellent. Great. That actually is a huge part of this test. If you, as far as the 1332 test, if you feel pretty good about that, that's a really big chunk of it. It's really just the probability that's missing, basically. Good. What would you like to look at next? It can be a specific question off the test. It can be general, like this one was. Anything that you feel you'd like to look at. Yes, Megan has a question. Go ahead. You can ask verbally if the chat is inconvenient.
That will be better. The local 7-digit telephone numbers in City A have 699 as the first 3 digits. How many different telephone numbers are possible in City A?
Great. So I'm going to write this down. So what it said is that you're looking at phone numbers, and in this particular area, the first 3 digits are all 699, I think you said?
Yes.
Okay. And actually read it one more time. I just want to make sure I didn't miss anything. So
The local 7-digit telephone numbers in City A have 699 as the first 3 digits. How many different telephone numbers are possible in City A?
great. So a 7-digit phone number is going to look like this. We know we've got a 699, and then there's going to be some more digits. This is actually we're going to be able to use that same thought process to see if we can use a formula. These digits that we're going to be picking, do we have something where we're picking few out of many? That may be a little harder to see, but do you see that we might be picking a few out of many? Little tougher, but the way I would look at it is you've got the 10 digits from 0 to 9, and you're going to pick some of them. So the first glance is, well, maybe I could use permutations or combinations. But then I get to the second question, and that asks, can I have repeated elements? So in a phone number, can you have repeated numbers? You can have repeated numbers. Yes. So as soon as you realize that, you know you cannot use combinations or permutations. Both of those are out the window. Forget about it. But the fundamental counting principle can still be used. And for that, what you do is for each one of those places that you're trying to figure out, you ask yourself, how many choices do I have for each one? So I'm going to go down a row here. If I think about this first digit, how many choices do I have for what I would put right there? 10. Right. So the 10 that I'm going to write down doesn't mean the number that there's, I'm going to choose the number 10. That doesn't make sense, but I have 10 choices. The underlying principle behind everything is multiplication. So it'll be 10 times, and then how many choices do I have for the second digit? Again, 10, because it never said you couldn't repeat. So 10 times 10 times, and then the third digit, again, 10, and the fourth digit. Oops, well, I started without you. The fourth digit is going to be 10 as well. Okay, so in this case, you can't use the formula. You just got to think about it as choice, 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 and multiply all those together. And that's going to give you, I'm not using the calculator on that one. That'll give you 1,000. Does that help? Right. So the question is, you don't think about the first three digits. Did I do it wrong? Oh, I sure did. It's 10,000. Yes, you're right. And the question was asked, do I think about the first three digits? No, I don't, because what they've said is that all the phone numbers will have that 699 coming up first. And so the only variation you have possible is in what's remaining. Does that make sense? You actually could, if you wanted to, you could think of it this way. How many choices do you have for the first number? Well, the first number has to be a 6. So you only have one choice for the first number. And then how many choices do you have for the second number? The second number has to be a 9. So you only got one choice for that. And then how about the third number? Well, it has to be a 9. And then it's only till when you get to the fourth number that you really get choices. And then you say times 10 times 10 times 10 times 10. And that'll give you the 10,000 again. So you can look at it that way. Good, 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 good. All right. What else? Are y'all okay with the probability part? Where we get beyond all the counting and we're looking at probability. What's the probability of drawing? Um, let's say something like this. What is the probability when you roll a regular dice of rolling an even number? The probability is not so hard. We didn't take that very, very hard. Are y'all okay with how we would do that? Okay, good, good. So just to be absolutely certain, probability is very simple. You take the number of, let me set up a fraction here. You set up a fraction. The number on the bottom, the denominator, is the total number of possible choices you have. And the number on top is the number of choices you're interested in. So when you roll a die, there's 6 possible choices. 3 of them are even. The probability is 3/6, and that's all there is to it. You do want to go ahead and reduce the fractions, though. And so that would be the same as 1/2. Good. That's actually a lot easier. If we had had time, the next section, I had to cut a couple sections out of the syllabus because we had less time after the break. The next section we would have done had some really hard probability questions, but I decided let's just, take a quick look, get the general idea, and call it a day. Okay, do y'all have any other questions, or you feel like you're pretty much ready to roll? I don't want to shove you away if you have some more questions. We still have time. If you feel comfortable with what's going on and okay, sounds good. We'll tell you what, best of luck on the test. I hope you both do great. Hope everyone else does too. If you do come up with any other questions as you're working, just send them to me by email. And even if we can't, figure it out by email, we can always set up a real fast one-on-one WebEx like this and do it this way. So y'all feel pretty good then? Okay, great. Well, I think we'll go ahead and sign off. I have been recording this. It'll take till tomorrow, but I will post this online and send you the link. And so good luck and hope you do great. All right. Y'all take care then. I'm going to go ahead and sign us off. Have a good day. Thanks, you too.